So hello API days. My name's Ahmet Soormally. I've spent several years helping folks like yourselves getting up to speed with modern API management best practices. More recently, I look after technical research and development within Tyke's product leadership team. So are you thinking about GraphQL? We have been and serve our customers. So we went ahead and did some research in the space to get our heads around it. So ideally that you don't have to. In this presentation, I'm going to be covering topics from some success stories, security considerations for your GraphQL API, how to apply GraphQL in a team or platform context, and how our journey evolved to what we call the Universal Data Graph. So in 2019, Airbnb software engineer Bree Bunge, she said that about 5.8% of all Airbnb traffic involves GraphQL. She expected that number to reach 10% by the end of last year. Before GraphQL, only 10 to 15% of their front-end code contained actual business logic. The rest was data handling and boilerplate. So GraphQL helped them to regain productivity by reducing non-business related code. GraphQL has become Shopify's technology of choice for building APIs. I'm not going to read the entire quote, you can do that for yourselves, but some key takeaways are reducing the number of round trips to the server, a strongly typed schema, and helping find and fix bugs before it affects Shopify's merchants. And we all know and love GitHub. It offers probably the world's second best known GraphQL API after that of Facebook. GraphQL has enabled integrators to gain access to the data they need. GitHub still offer a REST API alongside their GraphQL API. I want some of that too, I hear you say. So you're sold on GraphQL. How might you go about hooking up a REST API, for example? Maybe design and implement your schema, connect your data source, write query and mutation resolvers, ship to production. Easy, right? I'm pretty sure that we're missing something here. I could have spent this entire talk and more advocating about GraphQL and painting a picture through rose-tinted glasses, but that's not what I'm here for today. According to Google Trends, we can see that interest is steadily increasing with a bit of a COVID-19 blip. Given this apparent silver bullet, why isn't it exploding? All the success stories you hear out there, just why is interest in the technology not more exponential? Adopting GraphQL is not without its pitfalls. There are considerations for security, performance, and separation concerns. Who is responsible for what? Many of these problems, which have been long solved with REST, they're still truly in their infancy with GraphQL. The key takeaway for me is that each organization that I've mentioned previously and more, they accomplished what they did on their own, in their own way, using experts, and at a terrific cost. There's simply far too much to think about and address before just diving in and publishing your GraphQL API. So Tyke's initial goals were to understand where API management fits with GraphQL, how we can go about helping our customers to ensure that they can safely and quickly ship their GraphQL APIs using these tried and tested API management best practices, which we all know. So let's take a look at some of the challenges that Tyke aims to address, alongside why we think they might be particularly difficult for GraphQL APIs specifically. We've been talking to a lot of our customers, including retail, finance, government, across the globe, both seasoned GraphQL early adopters and those who plan to start using the technology very soon. I'm sure most of you here today are in one of these camps. So this is far from a complete list, but I've highlighted some 6 items which I think is actually throttling the mass adoption of GraphQL. Who owns the graph? The front-end developers, back-end developers, or the API product manager? How do I ensure governance for the GraphQL API without sacrificing agility? Do I need experts to manage the graph? Authentication, where does this occur? Authorization, should I be implementing authorization centrally or within my services, or maybe both? Protected introspection, is it desirable to be publishing my documentation to the outside world? Denial of service protection. How do I protect my server from becoming overloaded due to complex queries or bad actors? And how do I ensure quality of service for all of the consumers of my graph? And then schema traversal attacks. Can an attacker obtain information that they're not supposed to in some other way? So your front-end team want to consume this GraphQL API. Front-end teams or full-stack developers, they often own the GraphQL endpoint for their application. GraphQL is typically a facade to the underlying backend services, a niche backend for front-end. So where your front-end developers are responsible for the graph, they then become responsible for the security and the management of it. With the mantra, you built it, you own it. This might be fine for frameworks and indie developers and startups, but it doesn't quite cut it for GraphQL in the context of teams, enterprise use cases, and platforms and ecosystems. So given the success and value of our shiny new GraphQL API, the business wishes to publish a subset of it to a partner. How do should my front-end developers be responsible for securing the graph, nurturing it, and publishing that to those third parties? We've seen several cases where organizations who want to publish a subset of their graph have effectively architected a new niche GraphQL API specifically for that use case. Now, by handing the responsibility of the GraphQL endpoint to our backend teams, this introduces the possible necessity to re-architect our brownfield applications. It introduces tighter coupling and deep coordination between front-end, back-end, and external consumers. We also have many new roles which have been created of recent years, such as the API product manager, the DevOps. What about API governance? Where do they all fit into this GraphQL picture? How can the API platform team get involved to create wider value for the business? A super quick refresher on what authentication and authorization is and the difference between them. Authentication is about verifying who you are, and authorization is about establishing what you can do. In this diagram, which I've borrowed from a Medium article by the Guild, we've got a HTTP server that receives requests and then sends the request onto the GraphQL server, then onto our business logic. Let's take a moment to think about where authentication belongs in this request flow. So consider wherever you put authentication, it will impact both the behavior and the flexibility of your system. Now, type being in API gateway and management platform, we're quite opinionated in this regard, but others do it in other ways. From our perspective, by implementing authentication in your business logic, you open up a plethora of problems relating to, say, refactoring, breaking up into microservices, and then the necessity to re-implement that within each microservice. If you go ahead and implement authentication between your HTTP server and your GraphQL server, then you should be able to validate that the request is authentic by using maybe a third-party identity provider. And then you get the added benefit of being able to pass the current user and various attributes as necessary to your underlying services. Let's talk about authorization. In this example, we've got a library with books. A librarian should be able to add new books to the library, and the librarian will have their own application to perform CRUD operations in the library, on the books in the library. But a student shouldn't be, whilst they should be permitted to browse, search, and maybe even reserve books from the library, they certainly shouldn't be able to create, update, or delete any of the books. They probably should only get read access to a subset of the fields that the librarian would have access to. So with REST, you've got methods and paths, which you can protect with different permissions quite easily. But with GraphQL, because the query is in the body of the request, how would you go about protecting the library from the general public being able to modify and delete their books? Does this logic belong in the data source? Should each microservice or resolver, should each microservice need to apply its own authorization logic? And as your graph grows, how do you maintain visibility? Do you need a separate policy server? And if your GraphQL server of choice happens to support authorization, which specific features of it should you be using? We at Tyke think that GraphQL API aware API gateway is ideally positioned to handle both authentication and at least be the policy enforcement point for authorization. It can be done in almost the same way as a typical REST call, which you're all familiar with. We can have our centralized IAM solution, meaning that we can validate the token, check user groups, attributes, and scope, validate it with a centralized policy server, and all being well, pass the relevant user information onto the GraphQL server. Let's have a look at my fictitious and very, very naive schema and query above. Imagine I'm only allowed to view my own bank balance. Yet my query shows two ways in which I can access the bank balance field. One via through my user friends, and then one by querying friends directly. So assuming that I can protect this field, how can I also ensure that as my graph evolves, I'll not be accidentally opening up a new entry point to the bank balance field or any other restricted field for that matter? Unfortunately, as can be seen from the screen recording, causing havoc on a GraphQL server isn't too difficult without a proper means of rate limiting or limiting the complexity of a query. There are many strategies to address this, and a handful of examples might include evaluating the complexity of a query by maybe the number of raw bytes in the request. Maybe you would do it by allowing clients to send, say, 1,000 points worth of requests per hour, for example. So you add a score to the complexity of the query. And a third way, and the way that Tyke has introduced for our initial release, is the ability to limit based on the query depth. So an internal user might be able to send more complex queries than a third party, such as a public developer or partner. And third-party developers maybe they're on a pro paid subscription, and they'll be allowed to send more complex queries than, say, a free or trial account. Maybe you're monetizing access to your services, or your APIs are being designed for public consumption. For this, you need a public-facing developer portal. Now, normally, in REST-based services, you'd be publishing a Swagger documentation for your developers to browse, discover the capabilities of the API. We've got documentation for free, but with a protected API with granular permissions, why not present only the documentation that the access token is permitted to access? And back to security, though, in the majority of use cases, you might just be looking to implement your backend for frontend. So in this scenario, maybe you don't want the outside world to be able to query the schema, or to be able to query the schema for your graph from both a security perspective and also to help protect your intellectual property. So I hope that I've given you lots of things to think about. Going back over the list above, how many of these have anything to do with your business and solving business problems? And how many of these problems might be better abstracted away and centrally managed by your GraphQL aware API manager? So as we continue engaging with the community, clients and prospects, we realized quite quickly that in addition to the ability to secure a GraphQL API, our customers needed something more. The reality is that probably 99% of the APIs that we consume are brownfield services. Building an ecosystem with integrated components are fundamental requirements in the digital transformation of enterprises. Probably 15 to 20% of web services still use SOAP today. And not everything is legacy either. REST is still king. Microservices increasingly communicate over gRPC. What about my Kafka topics and Rabbit exchanges? So whilst GraphQL might provide the consumer with a blissful utopia and that next level experience, I don't believe there's currently a truly scalable solution to the integration problem. Unless, of course, I'm happy with that niche backend for front end, and I'm happy to rewrite my services, build my facades, and possibly be forced to introduce Node.js to my stack. It's simply impractical and it's expensive to replace all of your existing systems by building them from scratch, solely for the purpose of coding middleware to create that backend for front end. We see a lot of guidance on the web on how to migrate or rewrite your services to GraphQL, but not much in the way of how to go about composing GraphQL APIs from what you already have. After all, connecting your data to your users is what this is all about. The concept of the universal data graph at Tyke was born. Why can't we make it easy for our customers to have their own GraphQL API, be able to use it internally, publish for others to consume, and be able to publish their entire estate, whether REST, SOAP, gRPC, Kafka Stream, or more, without any of the pain or the necessity to have experts managing and maintaining the graph, and at a fraction of the cost, easily pluggable into your CI/CD pipelines. So with that in mind, I'd just like to take you through the final moments of this presentation with a quick snapshot of Tyke's new GraphQL engine. Imagine what an API product manager, platform team, or even a developer can get started. Getting started with GraphQL can achieve in just a few moments with zero code. So if you just bear with me for a moment, I'm just going to set up my demo. And you should be able to see my type dashboard in my development environment. Praying to the demo gods, I'm going to be creating a new API. And this API, I'm going to be composing a brand new API, and it's going to be for this service called Trevor Blades. And what Trevor Blades allows me to do is query a country. In this example, I'm querying Germany. I can see the country code, name, continent, lots of information about the country. I can send that request. So I'm going to compose a GraphQL API from this service. So we can start. I'm going to call it API Days Interface, because I'm very original. And I'm going to create a new GraphQL API. And I'm going to be composing this new GraphQL service. I click Configure API, and I'm just going to quickly scroll down and disable authentication for the purposes of this demo. I'm pressing Save. I head in. And now I go straight into the schema designer. So from here, I'm going to cheat just for brevity and find the country type. I'm going to copy that and I'm going to paste that in there. And I don't want this because I don't want to implement everything. So I'm going to be publishing a subset of this, of the graph. And I'm missing a query. So type query and country code ID, and this will be returning the country. And then I click on data sources. And what you can see, we've also got a visual designer, so we can also design our schema via a point-and-click GUI also. And what you'll see here is an exclamation mark next to the country type here. So we can see that a data source is required for this particular query type. I can click on the pencil, click on data source, define my data sources, and my data source type is going to be a GraphQL service. And what I can do now is paste the URL of our GraphQL API in here, and then update that field, and then hit update. Then we can head over to the playground, and I can write my query. And then I can send that. So after a while, adoption of my new API or my new GraphQL API is growing. But I find that I need some extra capabilities for this particular country type. I want to add, I want to enrich this particular country type with some more information. So we have another service that I want to enrich this with. So I can head over to the schema. And in the schema, I want to grab the borders of the country. And this is going to return an array string. And I also want to, I think it's called flag. I want to get the flag of the country also. And you'll be aware that obviously borders and flag doesn't actually exist on this Trevor Blades service. What I've got is a REST API, which I can enrich this with. So I can click on borders, I can scroll up, attach a data source, define a new data source, and what I've got is I can hook into services, this REST API, which Tyke is already managing on my behalf, Tyke REST. And I can choose my REST countries, and using the GoText template, I can take the object, which refers to this country object here, .code, and I want to send a GET request to that endpoint, and I want to enable field mappings to be able to get the borders and update that field. I want to do the same thing for the flag. So I'm going to define a data source and use a predefined template here. Scroll down, enable field mapping, and choose flag, and update that field. I can update this API, head over to the playground, and now, fingers crossed, demo gods, I can query the flag and the borders, and I can send that request. And you can see that I've pulled in the URL of the flag from my REST API and also the borders of Great Britain. I can do the same for the US as well to show you that I'm not cheating and it's actually working. So heading back over to the presentation. I really wish I had the time to show you more. Such as taking our GraphQL API, integrating it with the GritOps workflow, with this declarative syntax, the ability to publish between environments, or securing this GraphQL API also. But if you have any questions or wish to see how we've addressed some of the challenges that we've mentioned in my presentation, you can feel free to grab me in the booth after the talk. If you're to take anything away from my presentation today, I hope it is that adopting GraphQL isn't something that you just turn on. GraphQL is a journey, and it involves multiple stakeholders within the organization. Everything I've showed you today is available for you to use for free. And all you need to do is sign up for a free Tight Cloud account. I urge you to all to have a play, get in touch. Thank you very much for having me. Cheers.